Hello once again, welcome to Arduino Projects Lab. In this video, we will learn about the device that is called a relay. This is the relay in its simplest form. This is a relay module. This is a 4-channel relay, and this is an 8-channel relay module. Let us first take a look at the relay in its pure form. The relay This common relay has 5 terminals, namely the coils, common, NC, and NO. NC stands for normally closed and NO stands for normally open. Let us use this illustration to explain how it works. So these are the 5 different terminals of the relay. Here are the 2 ends of the coil. This is our common point, which is also called the armature. As we can see, it is currently connected directly to our normally closed. If an electric current is made to pass through the coils here, the coil becomes an electromagnet and it attracts this armature towards the NO. When this happens, the connection from common to NO gets closed and NC to common gets opened. Depending on the intended application, we can connect our devices to either the NO or the NC terminal. Let us now have a simple demonstration of this. This is our demonstration setup. So here is the relay, and these 2 orange wires are connected to the ends of the coil. This black wire is connected to the common. We also have these 2 LEDs and their respective resistors. This power strip on top is set to 5 volts, so it means it can power any device connected to it at 5 volts, and this one below is set to 3.3 volts. This particular relays work at 5 volts, so it will be connected on top of this. Let us turn on the power supply now and see what happens. As we can see here, both our LEDs are on because they are directly connected to the power supply. We will now connect our relay coils to the 5-volt supply, and first let us listen closely. If your volume is loud enough, you can hear a click every time the relay gets connected to our 5-volt supply. So here, take a listen. So that sound is the armature moving from our NC to NO pins. Let us now disconnect the green LED from our supply and connect it to our NO pin. I will switch this off first and connect this to our NO. Likewise, we will disconnect our red LED and connect it to our NC pin. Okay, now, as we turn on our power supply, we can see that the red LED connected to NC immediately turns on because the relay is now acting as a closed switch between the common and the NC terminal. The green LED is still off naturally because it is connected to the NO terminal. Now, when we energize our coils by connecting it to the supply, we can observe that the state of the LEDs are now reversed. The green LED turned on because the armature inside has moved to create contact with the common terminal. So how does this relate with our Arduino? We know that the digital pins of the Arduino are capable of giving an output of 5 volts through the digital write function. What we will do now is connect the relay to our Arduino Uno through pins 10 and ground. I will create this inside our examples bare minimum so that we don't have to always save it as a new file. So first, we will assign our pin number 10 as an output pin through pin node. And after that, we will simply just digital write a high signal to pin number 10. Turn this supply on. As we can see, our normally connected red is already on. And while we upload our sketch, Arduino Uno, the port is this, and then I will upload this. So it's there. As we can see now, the lights have reversed after switching it on because we have sent a digital write signal to our pin number 10. It energizes our relay, and now it has switched the armature to the normally open, and now our green LED is on. That is how the common relay works. This relay module here is designed to be used easily for connection with the Arduino. The working principle is the same, although the pin configuration is a little different. The common NO and NC pins are still the same. While we now have 3 pins here, this VCC and ground needs to be connected to a 5-volt supply. And this in pin is used to power this relay on or off. You might have noticed that there is this one big chip there. It's quite big on the module. This is called the optocoupler, which adds a safety feature to protect the system from electrical noise by isolating our Arduino from the load. With the common relay, we can see that there is an available conducting path between the relay and the system. With the inclusion of the optocoupler, that conducting path is eliminated. Inside this chip is a combination of an LED and a phototransistor. The LED is connected electrically to the Arduino, and the phototransistor is connected electrically to the relay. In essence, what the Arduino simply does here is to turn on the LED and send an infrared signal to the phototransistor to drive the relay. There is no electrical path between the system and the relay, which in effect isolates the two. So that is how a common relay as well as this relay module works. Now, if you have 4 devices to control, you can use this, and you can use this if you have 8 devices. And now here, and see, the middle terminal will be our common, and this middle terminal should be connected to the ground of power supply. So we'll connect this now to Arduino. 5 volts. This is program. is our module working on the blink sketch. I do hope that you learned something from our video today, but before you leave, let me express my heartfelt thanks to you. I really appreciate it. If you like this type of content, please give it a like and please consider subscribing if you are not yet subscribed. Also hit that notification bell so you get notified every time I post a new video. Please post your questions, comments, or tutorial requests in the comment section. Thank you once again, and I hope to see you later.